always forget that. So until we get on camera, we're live. I always forget that before I get on camera. So tonight, I'm also going to turn this off, I think. I'm going to turn my fan on. The light goes on. Now the lighting will be like, mood lighting. Hello, everybody. It is a little after 7. We're going to get going. And if you take a look at the thumbnail that I posted, that is the world famous, I don't know. It's not famous like the what is the intake that Freiburger used? Salad bowl. It's not salad bowl famous. It's just regular famous. But the Keglodon was a test that I did humoristically to demonstrate the effect of plenum volume, because people talk to me all the time about, and we're going to talk about this tonight, about what I call the little things, and people get so wrapped up in the little things, and some of those things, discussions have been happening. One of them today, and a couple of them earlier this week, which is interesting. But the thing is with the plenum volume is that it's one of those things like rod ratio and others where, for whatever reason, people get focused on like the little thing, and then they want to go down that path, and they just want to argue with you about whatever this thing is. You tell them, look, it's really in the testing that I've done, it's really not that big a deal. It hasn't made that much of a change. That's why when I do the testing that I do, a lot of times, we'll take a big swing at something. I tuck my elbow there a little bit. You'll take a big swing at something, and the Keglodons are like a perfect example of that. So we didn't just go, okay, what happens if I put a carb spacer on? Okay, well, what happens if I stack 10 of them, which I've done that before? What happens if I do a big tube and 2 flanges on? I did that. But before I did those, and those videos are up, but before I did that, we did the Keglodon just to take a really big swing at what happens when we add plenum volume. So we had this thing it basically is a beer keg that was, because I'm a big fan of Shark Week, we wanted to make it look like a shark. You go you get something in your head, you go down this path, you're like, okay, it's going to look like a shark. Okay, now how do we make it look like a shark? And so I'm trying to remember Chad's buddy that helped us out. I apologize for not remembering your name now. We were over there, well, it's probably been a couple of years now. It'll come to me. But he was responsible for a lot of and then also Jason over at JT Fab cut up a lot of the stuff. I just drew things and made templates, cardboard pieces, and said, here, this is what I was thinking, and then they helped make it a reality. But the thing is, what I wanted to do was I wanted to have something that had like a gigantic amount of plenum volume. So what happens, like we change the plenum volume a little bit, and we do it on a carbureted car or a carbureted motor. It also affects the signal from the carburetor, which then also affects power. Crosby, that's the guy I was trying to think of. Thank you, Crosby, again for the Keglodon. It was awesome. And if you notice, it's painted with like the Dykem blue for machining, the blue Dykem. Because I started painting, I'm like, oh, this looks really good. That's definitely got to be the color of it. So I wanted to make this thing big, and the beer keg seemed like an ideal kind of oversized like plenum that we were trying to do. And so we wanted to try this, and we ran it. It would attach itself to a Holley high ram, which worked out good because we could test a regular kind of lid and test this and show the effect of plenum volume. And as it turned out, it had very little effect at all. The intake runner and the portion of the Holley high ram that was working the way that it should, in the camshaft and heads and all those things, all of what I call, at least on a naturally aspirated motor, the big 3 things, all of those were there. It had enough throttle body, a big enough throttle body for the power output that we were at. The plenum volume resonating at some weird frequency didn't seem to affect the power band, either on the top or the bottom. It just didn't have a major effect. I thought for sure when we did this, having done these kinds of tests before, that we might see something somewhere. I didn't know going grand like this that was actually going to be a thing. But the point is that we tried it and didn't do very much or anything at all. And yet I still get people that I tell them, look, the intake needs to flow enough, obviously, to support the power, but it also has to have the runner length to be working in the right RPM range. Once you do those things, those are the really big things. Then we can start looking at little things. To me, the plenum volume is a little thing. But people get wrapped up in these little things. Another example of this is rod ratio. So I've had this conversation bordering on people wanting to argue about rod ratio too. They're like, yeah, this motor makes more than this motor because of rod ratio. I'm like, no, that's not why. This motor makes more than this motor, not because the rod ratio is more favorable or the bore to stroke ratio or any of that. This one makes more than this one because it has better cylinder heads and it has more camshaft and it has more compression. And oh yeah, it's also bigger. That's why it did that. So what I like to do and what I've done since the very beginning of doing this is, and kind of why I started going down this path toward testing things and telling people what works and what doesn't work. And not just that, we can tell it would be nice if the world was, hey, this works and this doesn't. This is the best cam and all these others are not the best cam. That would be wonderful, but it's not. So I have to show them not just what works and what doesn't, although a lot of times with camshafts, we can show you what doesn't work because they all really work. Same thing with cylinder heads, but there are little nuances. There are things that work better than others. Like we tried the keglet on, that didn't work. I've tried spacers on carbureted applications where it actually has changed the power. So it's not that it always doesn't work or that it always does work. In the case of a plenum volume, most of the time it does. Most of the time I've tested, it's done nothing. Sometimes when we test it, it has done something. So I'll never say that it never does that. Same thing with rod ratio. I know what rod ratio does, and we can do the calculations on what it does. But the thing is, in why I think it's not a big thing, and I think it's a very small thing, I've tested it on 3 different motors, and it did nothing. And when I say nothing, it did, like, you know, the variation was within 1 or 2 horsepower of just making one run to another run without changing the rod ratio. It did nothing on that. And so, and I can't tell you, other people have shown me stuff where it did make a difference. And I'd kind of like to see the test data and look at it a little bit more to figure out if that's actually really something. But, and I know that for, you know, very high RPM stuff for dedicated race motors, Formula One, yada, 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 that you need to start be thinking about stuff like that. In the kind of motors that I'm talking about that we're dealing with, junkyard motors or whatever, that shouldn't even be on your radar. That if you said, hey, I want to make 1,000 horsepower, rod ratio should never even be a thing that you discuss. And apparently making shark-shaped plenum volume shouldn't be that either. And I went through that again recently with somebody had sent me an email about talking about boost response. Their thing was that their turbo setup was so responsive because they had the throttle body mounted in front of the turbo. And I told them, look, that's not why it's responsive. Having it be in a vacuum is not what made your combination have a responsive turbo. Because again, it's the same thing. While that might help, just like rod ratio might help, like plenum volume might change it, there are other big things that have much more of an effect on that. Displacement and a power output, turbo sizing, the AR. You could get into a lot other things that would make nitrous, that would make more of a change than the position of that throttle body. The 85 Dodge that I have, the Omni, had the throttle body mounted in front of the turbo. So even if that does, you can show that that might be beneficial with the impeller spinning in a vacuum, although the turbine wheel is not spinning in a vacuum. One side is and one side's not, which is better than no side doing that, obviously. And there was this whole discussion about cruising and all kind of, you know, just, I'm like, look, dude, we could sit down and have a like civilized conversation that would go like, you know, over the length of an hour or whatever. We could talk about all this stuff. And trust me, I've got a pretty good handle on this, but it's a small thing. The thing, it's a rod ratio. It's a plenum volume. It's lots of other things that, you know, a guy wants to talk about. I don't know whether or not it has a roller tip on the rocker. That's the same kind of thing. If you want to make lots of power on an NA motor, the fact that your roller rocker has roller tips on it, it's not where you start. That's not the end all thing. But there's gonna be one guy that wants to come on and make a comment or comment on the video that's posted, and they're gonna say, look, oh yeah, these roller tips, this is the way to go. And what they're doing is presenting themselves as that being the big thing. And unfortunately, that's misinformation. While it might help, while it might have this much of value, actually value to it, I gotta close this thing. While it might have a little bit of value to it, it's not the main thing. Just like, if you're trying to make power, good heads, definitely good. The right camshaft, I have a dinosaur on, but this should say the right camshaft. The right intake manifold, all of those things are big things that make power. Displacement, big thing. Compression, smaller, I think, than the other things, but something that definitely makes power. Exhaust system, again, smaller than I think heads, cam, and intake, but also something that affects power. Whenever I do a header test, it's not usually nearly the gains that we get out of a header that we do out of an intake manifold change. If I go from stock exhaust manifolds, like on an LS is a pretty good example, go from stock exhaust manifolds to a long tube header, the gain that you get from that is not anywhere near what you would get from, changing a good intake manifold. An LS already has a good intake manifold, and especially an LS3. It'd be hard to get better than that. But you see what I'm talking about. Let's not make it an LS. Let's make it a small block Chevy. Changing the stock exhaust manifolds to long tube headers on a small block Chevy, which is beneficial, but not as beneficial as going from a 2-barrel intake manifold to a good 4-barrel dual plane intake manifold. You get a much better gain. But you see what I'm talking about. There are things that you change, and then the order that you change them in also can affect how much power you get. But there are things that are the big things. And that's what I want people to focus on first, and then go down the list of the other things. When we were talking about it the other night, if you're deciding that you want to have a turbocharged motor or a combination, how much power do you want to make? Okay, then you're going to have this kind of turbo for that kind of power. What are you using to make that kind of power? Okay, then you have this. Now, with those two things in mind, now you can start thinking about, do I care more about low speed response? If you do, then you should listen to Richard and put a small camshaft in it, because that's going to be much better. You're still going to have the turbo that does the thing that the turbo needs to do and makes the power, but a small camshaft. A long runner intake is also going to help low speed power. You're still going to have lots of power. Cylinder head, you can argue, that's kind of a personal opinion, but if it's less than 1,000 horsepower and it's an LS, I wouldn't change the heads. If you go beyond that, then I would start thinking about it. Again, esoteric stuff. That's a conversation that people need to have. That's not all yes, it's not all no. And that's why that I've been doing this channel for so long, and I feel like I've only scratched the surface of what needs to be talked about, because I can't just give you the answer in a headline and say all cams are great. I got maybe the best wrong cam response the other day, and it's good because I haven't had one of those in a long time. But he was telling me that there's no way that all cams are turbo cams, and that he won't listen to the data that I've supplied him, where I've shown him that we've run a turbo on a stock cam and on an NA cam and on a nitrous cam and on a blower cam and on a turbo cam. He won't look at that data. He just trusts that the cam manufacturers who have been in business for a long time and design camshafts, they make turbo camshafts. Therefore, turbo camshafts must be better. So I'm like, okay, I kind of understand that logic at least, but maybe data would be the thing to listen to. Not just me. I don't care if it comes from me, but lots of other people out there will now have data to show you that exactly happens, and so it does happen. So and if they listen to me speak for more than about 2 or 3 minutes on that subject, then they realize that I'm not saying that there aren't turbo cams. I'm just saying that there's lots of them. In fact, I'm a big fan of turbo cams. So we'll see what you guys got going on. I got to come up with a let's do a plenum volume. How about this one? Send the I'm going to make sure that I have the proper spelling of that. That's an A and an O, so that is right. And this obviously would be after they're done cleaning up, but we'll just kind of see what people think about it to see if they think it would be a good idea. Should I send the keg lid on intake to Cletus so he can try to run it on a car and hopefully run it like under boost? So that will be the thing. Hopefully he's there. I follow him, so I've seen the stuff that he's been doing. They're obviously cleaning up after the hurricane, helping people, which I think is a kind of a cool deal. So we'll send him some good thoughts. The ad below your live stream is advertising carbon fiber connecting rods. Oh, dude. We need to see that. I remember there was a test by I think a very famous individual who does lots of testing. They did a test at West Tech and they were trying to run carbon fiber valves in the cylinder heads. That didn't work out very well. Shot out a big wad of carbon fiber bits. But it was a cool idea. It was very lightweight. Back in the 80s, Joe Sherman died on a small block Chevy with a stock rod, and then the short rod was 15 pounds more torque, and the 6-inch rod was so the short rod made more torque, and the long rod made more horsepower. I'd sure like to see that. They argue over esoteric minutia and single horsepower changes. Yeah, single horsepower change is not a change because it's not something that if you can replicate it as 1 horsepower every time, that's pretty good dyno testing. I'd be more impressed by that than I would be by whatever the change was. Yeah, there is the wrong cam back there. Huh? That's right. I forgot about that one standing up. Rod ratio doesn't even matter in pro stock, and they're running a lot of RPM. Yeah, piston flip would be another thing on the list of on the small side of stuff. Rod ratio to me is always about engine durability. See, I'm not even convinced it does that. Because when people say a better rod ratio, what was it to begin with? Was it terrible? And did it, because like if an OEM picked a combination to run, they picked them to run at their power level and at their RPM level for a really, really long time. So durability is definitely a concern. So if they could put a 6-inch rod in it instead of a 5.7 rod and improve the durability, maybe they would, unless that is a cost versus durability thing. You want to create a gravity well? That would be interesting. If you could do that, you really could write your own ticket. Joe Sherman was the man. I did get to meet him. He was at one of the very first or second Engine Masters competitions, and he did really well. Yeah, Dan, a rod ratio test is a difficult thing. In your opinion, and from a metallurgical standpoint, what materials would be sufficient for me to experiment with liquid oxygen? Why do you want to inject liquid oxygen? Liquid oxygen is pretty volatile. Oh, did the rattling come back? I think I forgot to choose that. Here we go. Let's. That's my fault. And I listened to one of them today. The noise is bad. I can shut off and then come back on, but it's because I didn't change what mic I was using. We're using the one off of the camera, and that's the problem. Smokey and Visor would say long rods make more power, so there's 2. That doesn't matter that they say that. I just want to see the data. Pro stock engines want short deck heights to help the intake runner design. Yeah, that becomes a problem when you start changing things around as you make one thing optimum, and then it can affect others when they're trying to make everything optimum. Cam, long rods make so much sense to me. It does seem logical. It does on an internet level of things. It seems like that should definitely work. One with stock rods, and the other with longer rods. Wrist pin is higher. Very disappointed to report that I could not measure much difference. That's what I saw, but and again, in the RPM range and the power output range that we're running in, I just don't think you're going to see anything. There is a fan behind me. Ben's in the house. I think we know what the problem is. It's actually the autofocus in the camera. It's the motor that's in there. There was a long rod theory that was done long ago for one of the magazines, and it's not something that I would preach as gospel. Pro stocks have different intake runner sizes and different cylinder sizes, so they can maximize the power through the power band and maintain 15,000 RPM. That's good, except for Pro stock doesn't run that high. Do you need to increase rod length with an increased stroke? No, a lot of times you can't do that. Karen, back in the day, David Bouchard had a lot of research on long rod 4G63s. I remember reading about one of the 2.2 Chrysler deals where they were talking about a theoretical long rod that you could do with a tall deck block. But I don't remember about and I don't know about somebody proving that it made more power. I'd like to see the data. I'd like to see an actual test where somebody did something. Scuba Speed, I have a 5.3 project, VO delete, BTR cam swap. I have a 4-cam wheel and a 54 tooth. That would be normal Gen 4 stuff. So as long as your ECU is set up for a 4X and a 50, it wouldn't be a 54, it'd be a 58. A 58X and a 4X, then that should work. Somebody asked a question about the 3800. I don't have the heads yet for it. LS swapping an old body style K1500. Planning on build a true dual exhaust. Let's curious what diameter exhaust you think would be best for a 5.3. You could do 2.5 on that. Goes to 11. That's one of the things that's not real well. It's not a gain from a long rod or a short rod. That's a bore size versus stroke. So you're choosing that, and with the short stroke, it might mandate a longer connecting rod. So the bigger bore is there so that then you can have more head flow, and that's definitely beneficial. How's your schedule about doing the Pontiac 400? I already did a Pontiac 400. Please don't send it to Cletus. Please send it to me instead. I have no problem lending it for testing as long as you get credit. I don't really understand that. Thomas, they just don't want them to go as fast. That's why they shorten the track up. And they're still going. As soon as they were starting to go into the 320 range, they were like, yeah, we need to slow this down a little bit. I ran a test on different exhausts. We ran it at something that had more power than that, but we ran the dyno, the headers the way that we normally run it. We ran long tube headers and then just collector extensions. And then we ran the long tube headers with longer collector extensions and then 3-inch mufflers. And then we ran the long tube headers going into a full 2.5-inch, I think it was a Hooker exhaust all the way back, because there's enough room going back in the back of the cell at West Tech to run that full exhaust. And I don't think that this was like a 600 horsepower motor, if I remember, something like that, high 500s, the low 600s. And I want to say it was about 10 horsepower. Yeah, James, I don't know. Are the injectors, what are the pintles made of? And what is it freezing? Long rods. How about going from external balance to internal? Most race motors are internally balanced. I thought you were going to do complete build and more testing on the Planet 400. We probably will do a stroker version of the 400, I would imagine. So that's what it was. Dano's insurance company is telling them 1,000 feet. Does anyone know what the part number is for a GMPP Holley Hiram Copo 572 EFI intake manifold? Is it a 572 big block Chevy or is it a 572 horsepower deal on an LS? Okay, what I read is the long rod has less sidewall pressure and less rod angle. We know all that. We know what the theoretical thing is, but what we don't know is what the actual thing is. It's just like we know what the theoretical part of pin offset does too. We've done all the calculations on that, but when you actually tested it, it didn't do anything. So what does rod angularity do? If the rod angularity is like this, that's bad. If it's like this, and then we make it like this, does that do anything? How much horsepower can a stock rods and crank 351? We've done over 1,000. You definitely can run 100 shot if you're making 425 right now. My wife says you need more new t-shirts because she always sees the same ones. I put these on before I do my live feeds. My wife, she wants to know if you'd wear a t-shirt if she sent you one. She always see the same ones. I'll have to mix it up a little bit more. How did the interview go? I actually didn't do it today. Your car guide library is 8 times the size of any local books. I don't even have them all up there. I have boxes in these things and some down in the thing. I threw away, I don't know, boxes and boxes of stuff when we moved. You just ran out of enthusiasm for moving. F1 rods are really short, probably for aero. Yeah, because they want to. One of the things about the engines is one of their needs is a very compact design, because if they can get everything out of the airflow and also get the center of mass toward the center, that's a better thing. The laundry to connecting rod to lift stress on the wrist pin and the piston, which will theoretically create easily higher RPMs with less effort. This is what I believe. I don't know what the laundry thing is. Have you heard of race gas fuel additive? I have. I've seen that at West Tech, but I've never tested it. The problem is, to test it, you need knock sensor technology. Actually, what you need is a real test facility where they can actually tell you what the change in octane rating is with that stuff. Dave, you build 3 engines, a 347 Ford, a 350 Chevy, and a 340 Mopar. Which engine will make the best all? I don't know what you mean by best. You have to be specific what you mean by best all-around power. The one that would make the most power would have nothing to do with the rod ratio. The one that would make the most power would have everything to do with how you chose to, what heads you put on there, what, all the big stuff, heads, cam, intake, all of that stuff. Rod ratio would be the 15th or 20th or 100th thing that I would be looking at. She'd get a flowered Hawaiian shirt. I was just talking about that. Back in the day, I was all about like Hawaiian shirts and OP shorts, you know, way back in the day. Short deck, short stroke, short rods, big bore, big valves, big lobes, big runners, big compression too, obviously. Thanks for the well wishes. Rod ratio just shifts the piston speed around. Long rods have higher piston speed, near bottom end, etc. Yeah, it changed the acceleration rate at different spots. I did sign up today for on Facebook to be monetized on Facebook, so I'm very excited about it. And I've already made $1, so I'm well on my way to fame and fortune. Have you ever tried making a set of detonation headphones? We have done that before. I've also done it with just a piece of tubing. Is there no way to isolate the engine from noise from the dynamic? What do you mean? Can we hear the detonation? Is that your question? If that's your question, yes, we can hear the detonation. You have to make it detonate and listen for the noise that's specifically the detonation, because there's lots of other noises that are going on that you can hear, and it's very, very loud. Don't sell your soul to the metaverse. I don't think monetizing reels on Facebook exactly qualifies as that. Especially because I had no idea what it was when they sent me this invitation. Hey, you qualify for this. And I think that the reason that I qualified is because I've been posting stuff on Instagram, which I have an Instagram account that helps promote the stuff that I do on the channel, so that we can get people to go watch the videos. And then I would share that on Facebook as reels. And one of them now is blown up, which is the Boss 302 versus the DZ 302. And that has over 700,000 views, which I was very surprised. And oddly enough, that might be the first one that gets to the million mark. It'll be a little while, but it's right now about to crest 700,000 views. That's my #1 video right now. But when I posted that short reel on Facebook, it blew up. Everybody was sharing it and everybody was liking it. And now a bunch of the magazine guys and stuff that have all kind of jumped on the bandwagon and tried to they saw how successful it was. And so they try to come in and emulate that. And it's really funny. But because I've been sharing these reels across platforms, that's why they said, hey, look, you are already qualified to come and do this because you have a certain amount of things that you need. And so that's why I got that. And I thought, I'm just going to do it. I'm sharing that stuff anyway. It's going to go over there. I might as well get the extra $1. Then I can buy a frosty cold beverage at the end of a month or two. Send the keg lid on to Cletus. It could make you famous. I'm not worried about that. That's not why we do it. Actually, I wouldn't even care if he said where it came from. It'd just be funny to see people's reaction to it. What I would like to do, the ideal situation would be to send it there and have him do it around the time of Shark Week, so that then it has the potential to go globally viral. Not that he couldn't do that already by himself. So 84% are saying yes, that I should send that thing out. And then you can get some sort of cameo like Stanley. Stanley was the man. Stan was the man. I haven't seen the video who won Chevy or Ford. Well, the video was to demonstrate what these motors, I built duplicates of a DZ302, and shame on you for not seeing it, that you need to go watch it because you may push it over the edge and tell all your friends. If you could tell 300,000 or 400,000 of your friends, that would be awesome. But the myth was that a Boss 302 has the huge Cleveland heads on it, and so it makes no low speed power. That's not true. And the other myth was that the DZ302, the little 5-liter version that Chevy made for their Trans Am car, also, these things were underrated. They were rated at 290. These things easily made over 400. Again, like we were talking about with the big things and the small things, that's partially true and then partially not true. Like with the DZ302, it's underrated at 290. It makes more than that. In fact, it makes about what the 365 horse 327 and the 370 horse 350, they all make about the same peak power. The bigger motor, the 350, makes a lot more torque than either the 327, and definitely a lot more than the 302. They make about 350, 355 horsepower. So that part of it's true, but it doesn't make 400 horsepower. They weren't derated that much. They didn't make that kind of power. And also the Boss 302 with the big heads didn't have bad low speed torque. Because again, you got to get down and talk about what really happened. People look at one thing and decide this is it. Well, the Boss also had a much, much smaller camshaft, like 20 or 30 degrees less intake duration than the Chevy did. So it had bigger heads, yes, but they did flow pretty well. And it had a dual plane intake manifold. It had the same type of carburetor. It had all the things that it need actually. And the thing is that both of these motors were rated at like 290 horsepower. They both made very comparable power. The Boss made more on the top. It made about 15 or 20 more on the top. But it also made pretty good low speed power. And so I just wanted to demonstrate. I didn't care what they did. I just wanted to find out if that was actually true on both sides. Did the DZ302, did they actually, it was a high compression deal, gigantic camshaft, but it had heads that didn't flow very much. Relatively speaking, they flowed 200 or 210, whereas the Boss head flowed 275. So it was dramatically more, even with a very small camshaft that it had in it, where it wasn't taking advantage of everything that the Boss had to offer. But that's why I did that video, and people have really responded to that, and they did both on the YouTube channel. And the weird thing is that that video has been out for a long time. So it's just kind of tracking and tracking, tracking. Then all of a sudden, some group of people realize it and see it. And then YouTube says, oh, people are interested in that. We're going to start promoting this thing. And then I get a big jump and, you know, it'll go up 100 or 150,000 views like in a very short period of time. And then it'll kind of level off again. And then now it's got another VTech jump where it's jumping way up again. It's jumped up a couple 100,000 views in a very, very short period of time. So we just need another one of those. I want one of the videos to get to 1 million views. And I think what I was thinking about doing, in fact, that was going to be my poll for tonight is, and maybe we'll make that for tomorrow night, is if one of these videos reaches 1 million views, I think I need to do a giveaway, right? I need to give away an engine or something. I will say that it's important to understand what people like him are looking for versus what we might be looking for. 5 to 10 horsepower for a guy that may be a huge deal in a crowded field. Yes, but you're making the wrong assumption there. There's not 5 or 10 horsepower there. Not from these things that we're talking about. Not from rod ratio. That's not a thing. I mean, talk to Dan. He's done cup motors, so they've done development testing at the highest level. I did a little bit on my side. And there, if the cup guys tell you that there's no rod ratio, there's no power gain from a longer rod, it's going to be really hard for you to find an application where that's actually going to happen. So this myth that, hey, we're looking for that little bit of horsepower, that's okay. You should. When I was doing Engine Masters Challenge, I was looking for not 5 or 10. I was looking for 1 or 2. When I was doing my Del Sol, I was looking for 1 or 2. I understand what that's like. And then you go look at that. But you don't start off by looking at that. You start off by getting, what are the big things that I can get power out of? And what are the big things that don't cost an arm and a leg that I can get power out of? Now that we have that, now we can go looking for the little things. And like when I was doing Engine Masters, I looked and looked and looked and found a lot of things that either made no power, or more often than not, they would make some power, but they'd also lose power somewhere else. So we were looking at an average power production from 1 RPM to another. And that's all we cared about. We cared about the average horsepower and the average torque and the combination of those and divided by 2. That's the thing that we lived and died by. So we would get lots of applications where we would pick up more torque but lose power, pick up more power and lose torque. And so we would get a net zero or a negative number or gain a half a horsepower or something like that, even though we saw a pretty big swing in what we were doing. Then the question becomes, do you keep going in that direction now with that thing, with that change that you made? Or do you go back to something else where you had the same average number, but maybe it would take you down? There's a lot of stuff to consider when you're doing that. I read in Mopar Action 25 years ago that Chrysler considers a rod ratio of 2 to 1 optimum. There's a lot of power in idealizing the air fuel in each cylinder. I haven't seen that either. When I did the test on individual cylinder tuning, and we had some that this is a single plane intake manifold, so naturally we had some wild variations in air fuel. And I ran it carbureted, and then I ran it with batch fire, and then we ran it with sequential, and then we ran it with sequential doing individual cylinder tuning. And when I went from batch and sequential to individual cylinder tuning and tuned them all so that they were all like 12.8, I want to say it was nothing. It might have been a couple of horsepower, but it was not what I was thinking of, especially since some of them were like 14 to 1. Richard, we do a video where you perfect the airflow into each cylinder. I thought you were talking about air fuel. Did I just go off on a diatribe and then random Norwegian? Norway's in the house. Waiting on some Volvo red block B230s. Yep. you see the cup car bird song picked up? I did not. 75 Pro Stock Duster cam headers would be cheaper. Turbo would cost much more, but have a lot of potential. You have a Pro Stock Duster? Big question. If I ran a form of water fuel injection on a Ford 300 6-cylinder where the EFI manifold sits around, why is the EFI manifold 200 degrees? What kind of powder do you think I'd pick up? If the intake manifold is 200 degrees, is the intake 200 degrees or is the air going through the intake 200 degrees? Because those are a big difference. My guess is the air going through the manifold is not 200 degrees. In fact, I'm going to guarantee you that it's not, unless it's under boost. You're probably going to pick up nothing, because what happens is, and we've talked about this many times, is that the airflow through the intake manifold doesn't have enough time to pick up temperature at the airspeed that it's going through the manifold with. There's a boundary layer. There's temperature just can't jump off of it, even if the manifold's hot, can't jump off the manifold and get into the airflow. It doesn't really do that. What you might pick up is, if it even did this with the water meth injection on an NA motor, I don't even think it would do that. Cooling the charge air from the air, I don't know where you're getting this air. If you're getting underhood air, then you're getting hot air. But it's not because the manifold's hot. It's because the surrounding air is hot. It's got a 750 horsepower small block from Yates. The air in the intake is 200 degrees. As it came off the manifold temp sensor, the exhaust manifold sits right over the exhaust due to I know what because it's not a cross flow head, right? They're both on the same side. So the air intake is 200 degrees. If the air temperature is 200 degrees in the manifold, then you should be able to pick up power by lowering that. The first thing I would do though is get cold air to it. Is it breathing underhood air or something? Even if the exhaust is sitting right next to it, if you have a dedicated cold air source, it's still hard unless it's just sitting there idling. It's still hard for the temperature to get that hot. Apparently I picked the right discussion, right? So we're at 83% saying yes on send the intake and 17% saying no. But Dan, you got all the EGTs the same. Now you get all the air fuel mixtures the same. What it really needs is more airflow. I'm curious as to what Cletus would run the keglet on be beneficial. I don't think it would be beneficial for anything. I think it'd be awful. It's terrible. It's going to be terrible for aerodynamics, and it's not going to make any more power than just running any kind of high ram on there that he would have already. But I don't think that that's why he would do it. So Project 23, are you going to run a turbo on it? If you're going to run a turbo on it, you need an intercooler and you need a cold air source. And then if you want to run water meth, you can try that too. Richard, here's the real question: long stroke versus short stroke. That's not the same question. They would be related, but are we changing the displacement there too? If we're not changing the displacement, the long short stroke stuff, and we've talked about that already, the displacement is the big thing. The fact that you get it with stroke or bore is a small thing, because in all the testing that we've done, Freiberger's done a bunch. When you have a motor of a given displacement and one has a bigger bore and one has a bigger stroke, they really make the same kind of power. There are instances, like we talked about, if we want to look at the little side over here, where if you want to run lots of RPM and you need lots more head flow, and you can make the bore bigger to take advantage of the head flow and get more head flow and get more air in, and I guess more engine speed and make more power, and all that then goes together. But I don't think that that's a bore and stroke thing. How did you get from displacement but with boost doesn't matter, so short stroke is arguably stronger? Why would short stroke be stronger? Do you think that the crankshaft is going to be stronger? Like, if you a bunch of testing ported peanut heads or ported peanut port heads. I've already run ported peanut port heads. Bob Hayes won the '64 Olympic 100-meter dash using a chug technique where he favored one leg. It was the wooden one. Because you have too much airflow across the intercooler to where it doesn't cool down air charge as good as lower airflow. I remember people making that argument on coolant flow inside the motor, that the coolant flow passes by the hot engine parts, internal parts, that it needs to stay in contact, and that's why they pressurize it, because it pushes it against it, so it aids in heat transfer. That if you flow it too fast, I don't think the same thing happens with an intercooler core. If you have an air-to-air core, the more airflow that you can get going past that, the better, because all you're doing is you're cooling the core off. So I don't think you'd have too much airflow in that situation. Lower moment on the crank means less peak stress, lower peak piston. The same RPM. Okay, I guess we could see the math, and you could do an engineering drawing and figure that out. Bore stroke is interesting. I'm curious to see if the 350 Pontiac has some of the small bore limits encountered for bore notching. That would be one of the considerations. That would be the same argument when if you were comparing like a 305 Chevy to a 302 Chevy. One of the big things is that you have a lot more cylinder head available to you, and I guess you could notch the bore on the 305 to try to improve that, but you still don't have everything in terms of bore size that I think would help with airflow. I don't know at what point, like on a 300 horsepower version of both those motors, I don't think it makes any difference at all. In fact, I don't think it makes any difference at all for a fairly good range until you get up into higher power, where the more airflow definitely comes in handy. The problem with it is that I don't know what that point is, because we have a pretty good cylinder head available, and especially in ported form, for a 305 versus a 302 test. But you could put, theoretically, a much better head on the 302, because there's a lot of 4-inch bore heads that flow a ton. I mean, you can get a 300 plus CFM head for that 4-inch bore on a small block Chevy, but you can't get that really, I don't think, for the small bore 305. Like for that 175 Super 23 head from TrickFlow, which would be the one that I would try on a 305. And on the Pontiac, the hard thing is that you don't know, like, are you going to build a 350-inch Pontiac that's a different bore size that has a shorter stroke? I mean, you'd have to try that because you need to run the same head, but then the stuff that I just talked about with a 305 versus a 302. Building a 5.3, I have two GTX 3576s, Gen 2s, 10-to-1 compression, H-beam, stock 862 heads. This is for drifting. What do you think about a Trek Norris cam? I think it would do that. Are you needing a lot of RPM range for drifting? Like, I don't know what the RPM range usage is to get the tires to spin and constantly spin. I don't really have a feel. I haven't seen data logging on any of those to know what they're doing with that. The turbos are certainly enough. 10-to-1 compression is going to be good. The stock 862 heads, you're sub 1,000 horsepower, so those will be fine. The Trek Norris cam would be plenty torquey, so I think it will work. I think we just ran the port at Pina heads on something. I don't know that I did a test on comparing them to a stock set, because I think that's the only set of heads that I had at the time. So Mike, what is your real world proof of? Every one of GM's boosted motors all have 3.62 strokes. They can make a 4-inch stroke, but that doesn't really tell me anything. That tells me nothing, because while you're listing all of their boosted motors that have the 3.62 stroke, 90% of their NA motors have 3.62 strokes. The 5.3, the 6.0, the 6.2, all of those NA motors have that too. Why would they put a 4-inch stroke in that? They don't put a 4-inch stroke in anything else except for the LS7. So why would they do that? They wouldn't. That's the reason. Put the 4.3 LT1 crank. The L99 is what you're thinking about, and put that in a I want to put that in another. I want to swap the stuff from an LT1 to an L99 and vice versa, and then we end up with a 302 and then a 305, I think, in the other one. Casey, you have a 50 BMG? That's a serious gun. Oh, we're getting into laminar flow discussions now. P-51 was the first aircraft with laminar flow wing. GM has some of the best engineers of all manufacturers. They know the shorter stroke can get it done with less stress. If you're making that argument, then everybody here should be bringing up, why didn't they use the 4/8 stroke? Why didn't they use the short stroke? Trust me, and the reasoning that any manufacturer, not just GM, and obviously I'm giving you a hard time, Mike, but the reasoning behind a person's or engineering team's choice of a particular stroke would have nothing to do with what you're talking about. That's not their criteria. Their criteria is a list like this long of stuff that they have to get done for that project, and and maximum power potential or load potential is not one of the things. Cost is the number one thing. Can you tow the Turbo 454? You can. The tune would be really critical. Larry, you've got a 3875. I ran a 38. I thought I ran a 3875 stroke in. I want to say it did like a 406 or something. No, I had a weird. I had that wasn't it. We had a 3. I think I had a 3750. No, I'm trying to remember what my 406 was. Whether or not, I think it was a 400 block, but it did have a weird rod in it. It had like a 5850 or something rod in it. What kind of power do you think a modernized version of a Boss 306 using techniques like Windustry? What do you mean a Boss 300? Like the inline 6-cylinder one? The Gen 5 stuff is more of a pain getting cam gears off and back on compared to an LS. I agree. The Gen 5 is going to be more work than what we're normally used to on a Gen 4 or Gen 3. Do you recommend disabling active fuel management? Isn't it going to help? Isn't it going to lower your fuel mileage? The engineers, especially people out in the aftermarket, have no idea what level of testing and development and stuff that goes on at the OEM level. They just, most guys just can't even fathom it. The guys that think that, I get this a lot from tuners. They were like, oh yeah, I know how to tune. These guys left a lot on the table. Yeah, they did, and they did it on purpose. You don't know how to tune a GM motor better than the GM engineers do. If they wanted to do all of that stuff that you're, I cracked the code. No, you didn't. Somebody gave that to you. If they wanted to do that, they could do that. They're really, really sharp guys. If they wanted to develop the motor differently for maximum power, they could have done that. If they wanted to run turbos on them, they probably did do that. They could have done all that. They're really sharp guys, and they do stuff at the level and intensity that regular guys just have no idea. Son bought a 2002 6-liter last weekend for his Dakota. That would be good. I've seen trucks that have turned DOD AMF off and picked up mileage. I don't do that kind of stuff out on the street, so I don't really get to see any of that. I want to see what increasing stroke does as opposed to bore on an LS. So you could put a 4-inch stroke in a 5.3, and when we do the big bore, we make it a 383. But I don't know what it's going to be at a standard bore. Nice to bump into Tom Vaught. That name sounds familiar to me. I think I've talked to Tom. I meant for the Boss 300. Is a Boss 300 the Australian motor? Am I not familiar with that? I thought we were talking about a 300 inline 6-cylinder Ford. Are we talking about something else? Should plenum volume increase with displacement? I don't know. I don't have an answer to that. I don't think so. We've run the same intake manifolds on 351s that we run on 408s. And I don't remember doing a test where we ran one, where maybe we ran stacked spacers on the 351 and then stacked it on a 408 and then said, okay, well, it liked it more because of the displacement. Did it like it more because of that? Did it like it? If it did like it, first of all, we don't know if it did like it, but if it did it like it more because of that? Did it like it more because we had different heads, or certainly different cam timing would affect that? We had different cam timing. Do we have a different carburetor? All of these things. What exactly the test that would be required to evaluate that, I think, would be a lot. I think I did talk to Tom. I think, as a matter of fact, I'm sure of it because we met out at I think we met out at Bonneville. It's a Ford 306 with the Cleveland heads cut and welded. Okay, so I know what that is. That and that combination made to over 600 horsepower. That seems like a lot. So we're going to close our poll at 82% saying yes, the Kegladon should go for a trip. Have you ever done an NA high compression LS build? Yeah, I did. I have a couple of them up. One of them was a 468 that was around 750 or 760. The other one was a fairly high compression 495, so it was a tall deck block, and that one made 820 or something. Those are not real high compression. Those are probably around 12 to 1 or 12.5 to 1. The Vega engine wasn't a good idea. I think Dan would argue that the Iron Duke was not a good idea. Does flame travel take longer in a larger bore? It certainly does in a bigger chamber, but the bore should affect the timing also. Richard, best bang for the buck tall single plane intake manifold. Well, if you want cheap, then you got to buy a cheap one. I think Westech tested a bunch of single planes, and I don't have the data to see which one of those. I don't remember doing. I don't think I've ever done a test on different single planes on the big blocks, but I know that they have at Westech. Streetable or high compression LS engines, they're not. I mean, you'd have to run really high octane in them. And they had big cams in them and stuff. If I was building a street motor, it wouldn't be either one of those. Although Brian drove his 700 horsepower 454 that he did, and it was fairly high compression, but he had a pretty good sized camshaft in it, and he drove that on the street and ran it on pump gas. Richard, do a test on a stock LT1 intake manifold where you mill the top of it off and weld the giant plenum on. I'm already halfway there because I welded but I think I did that on L98. We welded a carb flange on it to try to run a carburetor on the tune port manifold, which didn't work out very well. But an LT1 could certainly be done. $30 horsepower wet shot for a turbo spool. Yeah, you can do that. And even below 3,000 RPM, you can do that. What percentage of DODs actually fail? I don't know about that. What's the highest compression you'd run on the true 85? Well, that's never, when people ask that question, to me, that's the same as how much RPM can I run or how much boost can I run? You should step back and not ask that question. The question you should want to know is how much power do you want to make? And then how are you going to go about doing that? Because static compression and octane, while they're related, it's not exact. Because it might be 14:1, but you might have a 300-degree duration at 50 camshaft on it. Might run on pump gas. Any opinion on a 3800 Furel swap? I think it's an excellent idea, especially a supercharged one, and a turbo one would be even better. Colorado's in the house. The Boss 300 had a slightly shrunk port to increase velocity, but set a bunch of records and was banned at a lot of tracks. Cords is in the house. Well, who did the Boss 300? Was it just somebody that did it on the side? New Mexico's in the house. Opinions on belt drives versus chain drives. Is it a big block application? GM never put a 4-cylinder in the first-gen Camaros. I didn't think that they did. They had inline 6-cylinders, though, right? I think I would use a double roller timing chain on a marine motor. I can't remember, other than dedicated race motors. I think most of the marine motors I've seen are all chain drives. Sherman Sly made the 300, got banned from small block classes, then placed it into big block classes. If it had the Boss heads on it, that would be, you can make those flow a lot. The guys that are doing LS ones, I think, should work really well too. Charles, Dan is correct. Wow. Best hit for 1980, 267. I think I would use the one that we use on the 305. I think I would use that 175 Super 23 trick flow head. When is a double roller timing chain on a necessary on a 5.3? As soon as we find an application where that's necessary, we will let you know, because that hasn't happened yet. Maybe if you're running a solid roller, maybe on Ben's spinal tap thing, maybe that's necessary. Does a double roller timing chain fit on an LS? It will, but you got to move. You got to move other stuff. You got to space the pump out. You usually have to machine the front cover. If I could ship a running Cleveland headed 306, would you? Oh, I would definitely run that. What would be your suggestion to get 600 horsepower out of an NA351? To get 600 horsepower from an NA351 is going to take a lot of camshaft and a lot of compression, and it's not going to be a drivable thing. You can make the 351 bigger and make a 408, and I have 408s up there making more than 300, making more than 600 horsepower. But again, it's still a pretty big camshaft. It's really easy to add a turbo or a blower to that and then make that kind of power. And it'd be much more drivable because you don't have to have very much camshaft in it to do that. Can I use stock valve springs on a 317 LS head on a 350 Vortec to use a higher lift cam? I don't know if that's going to interchange or not. I don't remember about the how the spring locates. Yeah, Garrus, that's a good point. And that'll be the last comment for Senate. I got to get going, but it'd be much cheaper to chop up junkyard LS heads because you can find a million 706 or 862 heads. Guys, just those are, you can walk around and just find those laying around. Then it would be to chop up Boss 351 heads. You wouldn't want to do that. If you're going to cut up a 4V Boss head or a 4V Cleveland head, don't make it a Boss head. Make it a regular 4V Cleveland head if you're going to do that. But even those are just getting harder and harder to find. And on that note, it's time to go. So remember, do the big things, then think about the little things. And then whenever Richard brings up rod ratio, tell him, not again. Stop talking about that stuff. It doesn't matter, or it does matter. And then everybody will argue again. I will see you guys all tomorrow. Go watch the video I put up.